work with the operations on whole numbers is at the core of the elementary school mathematics program. Readiness for this begins in the preschool years, as children learn to use one-to-one correspondence.
Good morning, boys and girls.
Good morning.
How are you?
Fine.
Better take our lunch count now, so you have to think. Did you bring your lunch, or you bring your milk, or what? Okay, why don't we start out. If you need to buy lunch at school, please stand up. Will you count with me, please?
1, 2, 3, 4, 5, 6, 7, 8.
Now, if you brought your lunch, so you need to buy, would you please stand up? Milk. Would you count with me?
1, 2, 3, 4.
Now, if you brought lunch and you brought milk, so you need to buy nothing, please stand up.
Research has shown that proficiency in counting and work with sets facilitates the learning of addition and subtraction. And most kindergarten and first grade teachers plan activities which will strengthen this background. We know from research that the greatest sources of pupil difficulty with all operations are due to lack of knowledge of basic facts and lack of understandings about the operations. We are constantly aware of the need to teach basic facts more effectively. Some studies have shown that clarifying the interrelationship of the operations facilitates understanding. Thus, these first graders are focusing on the relationship of addition and subtraction.
How about doing it with some more people? Why don't we have Mary Ann and Brenda and Shoda and Alan, please? Stand up. Now, everyone tell me, how many people are standing up?
4.
I want to change that. I would like some more. We'll ask these two boys to stand up. Mark and Charles. We had 4 plus 2 equals
6.
Good. Well, 6. I don't know if that's... Let's see what we can do with 6. Why don't we have 2 people sit down again? We have them stand up, sit down, and now we're back to
4.
Okay, thanks. You may sit down. See this chain of beads I have?
Yeah.
Do you see how long it is? How many beads are in it, Mike?
4.
4 beads are in it. I don't know if I want this to be 4 beads long. I think I like it longer. I'll add this many, Johnny. How many is this?
6.
Okay, and how many is just here?
2.
2, and if I add 4 plus 2, I'll have?
6.
Could someone come and write that equation on the board for me? Chalkboard? Steve? I'm going to start with 4 that we had plus 2 equals 6. Thanks, Steve. You know, sometimes I change my mind. This is probably too long. This is probably too long. Why don't I just take these 2 off again? Now how long is it again? Daddy?
4.
this what it was like before?
Yes.
Could someone write that equation of what I just did? Mary Ann? She remembered to start with 6 minus 2 equals 4. Good, Mary Ann. Let's read that one together. 6 minus 2 equals 4. How many did I add in this equation? I had 4, and then how many more did I add? Charlie?
2.
Down here I had 6, and then how many did I subtract? Johnny, how many did I subtract?
2.
So I added 2 and I subtracted 2. Let's try another one. I think I'll just take 3. Who can tell me how many do you want me to add? John Case, could you tell me how many you'd like me to add to this?
3.
Okay. Just happen to have them right here. Is that right, John? Okay. Now how many, Susie?
6.
Could someone come and write that addition equation, Leslie?
Notice the use of varied materials. Now the teacher has pupils write equations or math sentences on the board.
And maybe you could write it up that high.
She went on to have them use individual beads and make up equations.
Mike, do you want to tell us what you did? How many did you start with, Mike?
3.
3.
And I added 3 and I have 6 left.
Thanks, Mike. Who wants to write that equation on the board? Is that Mike? Brenda? Maybe you could go over here and try it. Started with 3 plus 3 equals 6. Thanks, Brenda. And Mike, then when you had 6, what did you do?
I have 6 and I subtracted 3 and I have 3 left.
And you were back to 3. Would someone like to write that equation? Dottie? Now look at those equations. Here's the one I started with. When I began with, and I added 2, I got
6.
and then I started with 6, and I subtracted 2, and I was back to
4.
just sort of doing something and then undoing it.
Yes.
You know, I have some equations up here too, and I'm the same one on the flannel board. 4 plus 2 equals 6. 6 minus 2 equals 4. Do you see some numbers in there that are the same? Do you see in these two any that are the same? Charlie, what's the same?
These 2.
Okay, what did you do here? What does that say?
Plus 2.
And
Minus 2.
Charlie, could you join the two that are the same with that piece of felt? It's the same. Adding, and then you're subtracting the same number. Any more that are the same? Charles? What else is the same? How about him? Can you do those two? Anything else the same? What number is that, Charles?
4.
Practice work is also directed at strengthening awareness of the relationship between the two operations. In this lesson with third graders, several forms of arrays are included as aids to understanding multiplication. Notice the application of the commutative property as they rename the number.
Somebody said, somebody named this a particular way. Somebody before, and I can't remember whom. How could you name it?
3 times 8.
3 times 8. Why 3 times 8? Yeah.
Because
Go ahead.
there's 3 sets of 8
Where are the 3 sets of 8?
on the building.
Okay, there's one set, another one, a third one. How else might you name it? Yes.
8 times 3.
Why?
Because there's 8 and there's 3 sets.
All right, just the opposite, the reverse of it, all right. How else?
4 times 6.
Would you be likely to just look at that and name that as 4 times 6? Would you name it that way? Why not?
I don't know if it's...
Why wouldn't you name these as 4 times 6? Or why would you? Maybe you would. Why would you? Where are the 6 rows?
There's 6 rows of 4s.
Oh, okay. So you could name it that way. Any other way?
4 times 6.
What's it say?
4. 6 times.
Any other way?
12 times 2.
Why?
Because there are 12 sets of 2
Where?
on the windows. There are 2, one on top of the other, and 12 of those.
Everybody see it? All right, and if you name it that way, what's another way that you could name it then? Yes.
2 times 12.
Okay. Any other way? Think of any other ways? There are other ways. Look at the blocks on your desk. You have them in groups of 24 right there. See if you can figure out any other ways that you could arrange those to make 24, to show 24 differently. And any other way to name 24 other than the ways we have on the board. Somebody who has a pattern over here that's possible. Let's see how she names it now. I don't see that you have 6 times 4 there, though. I see that you have something else. I see that you have that as one factor. Can you go on from there and name it now another way? Everybody look at... I'll make a very quick drawing of what she has on her desk. It's not going to be a very good picture of these arrays, but would you agree that's what you have on your desk? All right, and I said I could see another way that she could name that using 3, but different from any way we have over here. Anybody else see it?
3 times 4 2 times.
Agreed? Okay, see if you can find another way that uses 3 factors. Somebody just suggested this.
That's too much.
How do you know it's too much?
Because that's 12 times 4.
All right, that's the same as saying 12 times 4 because that's 4, but we already know that that's true, therefore that can't be true. Okay, how else? Yes.
I think 5 times 4 1 times 15. 5 times 4
Yes or no? You're disagreeing with yourself. Everybody agrees that this is another name for 24? Everybody raise your hand if you think this is another name for 24. Raise your hand if you don't believe it's the name for 24. Why don't you think it's the name for 24? 5 times 4 is what?
20.
And if you multiply 20 times 4, what would you get? 20 times 4?
80.
And so if we named it this way, we'd be all right. We take 5 times 4 plus 4, but not in a group pattern. You know what we've been doing? We can also be shown over here on this chart. I guess I'm a little tired of hearing the blocks, and that's why I want you to look over here right now. Put the blocks up at the top of your desk and just leave them there. Okay, watch what I'm going to do up here. What am I showing there? Yes. 24. Everybody agreed? But I'm showing 24 in here. Who will come up and prove to me that that's 24? However, you can prove it to me. Do it out loud so I can hear what you're doing.
2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22,
Okay, how many is it? Anybody else got a good guess on how many it is? Like 35. Prove it. If you can follow where the dots are, I'll put my fingerprint in there. There's 35. And we still have some more, so it's not 35. Can somebody tell how many it is now? Yes. 42. Let's everybody finish off. Here's 35, 36, 37, 38, 39, 40, 41, 42. How else could you have told that that is 42? Or how else can you tell now that that's 42? Yes.
You can take like 6 down the side and 7 across, and 7 times 6 is
6 there, and 7 there, and 6 sevens are 42. Very good. How else could you tell? Yes.
7 on the bottom and 6 going down.
All right, go the opposite way. How else could you tell? I thought for a minute somebody was going to do that before. What happens when you just count across here and you say 1, 2, 3, 4, 5, 6, 7? What do you know about how many there are in each row? 7 or each line across that way. Then this must be 7, 14, 21, 42. All right. How else could you do it? You can do it counting by 7s. How else can you do it? By going across this way. Let's do it.
6, 12, 18, 24,
36, 42. All right. But you know you had trouble in there. How could you use this idea over here? Using this.
Algorithms used to record work with operations cause difficulty for many children. The use of multiple approaches, allowing pupils to reach solutions in many different ways, enables each child to find a way he understands, allowing him to work on his own level. Underlying each of these is the distributive property of multiplication with respect to addition. Use of a diagram also facilitates computation of the product. There are certain strategies which can be used across all 4 operations with whole numbers, as well as with other rational numbers. Research shows that to facilitate achievement, retention, and transfer, instruction in mathematics must be meaningful. The use of materials is an essential base for developing meaning and understanding.